Hello and welcome to this lesson about operations with mixed numbers. The learning target for this video is add, subtract, multiply, and divide mixed numbers. So first, I want to talk about the failsafe and the fine print. The failsafe is to convert everything to improper fractions. If you do that, you cannot go wrong and everything will be just fine. All right. But there is a little bit of fine print. Now, there's a line in the sand with the fine print. With multiplying and dividing, you have to have improper fractions. There is no two ways about it. Oops. Improper fractions. Okay, so you're going to have to convert them. But for adding and subtracting, you don't have to, you could work with mixed numbers. And I'll show you. But first, let's talk about how to multiply and divide, because there is only one way to do that, and that is to use improper fractions. So let's look at multiply. Start there. And what we're going to do is we're going to use the same mixed numbers for all of these operations, just to kind of show you how it works. So the numbers I'm going to use are 5 and 3/5, and then we're going to multiply it by 3 and 3/4. Now, when it comes to multiplying, the big mistake that many students make is they try to go 5 times 3 and 3/4 times 3/5. Don't do that. Okay, that is wrong. What we have to do is make improper fractions. So let me write that. Improper fractions. Super duper important. That is the first step. So we'll do our little C trick for both of these. 5 times 5 is 25. Plus 3 is 28 over 5. Times, and now 4 times 3 is 12. Plus 3 is 15 over 4. Now we're dealing with a multiplication problem with fractions. And I urge you to simplify early, because I don't know about you, but I don't want to multiply 28 and 15. That's a lot of work. I don't mind multiplying 5 and 4, but if I had to, I could multiply 28 and 15, but I want to see if I can avoid it, and I can, because 28 and 4 share a common factor, and that is 4 itself. So 4 becomes 1, and 28, when you divide it by 4, becomes 7. And then I look at 15 and 5, they also share a common factor. I'm going to get a 1 here, and I'm going to get a 3 there. And so what I'm left with is 7 times 3, which is 21, over 1 times 1, which is 1. And we would reduce that to 21. Now, it's not always going to be this neat where everything disappears. You might end up with an improper fraction, and that's totally fine. Okay? But the big thing I want to stress is that you have to make it an improper fraction. Now, let's do some division. And again, we're going to use the same numbers. And I think what we're going to see here is that it's not going to be as pretty. So division. There we go. Wait, I'm having a brain fart. How do you spell division? It has the I there. There we go. Okay, so again, same numbers. 5 and 3/5 divided by 3 and 3/4. Okay, we see fractions and we see a division sign. We have to think, keep, change, flip. We will do that, but again, we need to have improper fractions. So that is the first thing we have to do. So we'll make our improper fraction using the C trick. Use the C trick. And so we'll get 28 over 5 divided by 15 over 4. Now, we're going to be tempted to do what we did on this problem. We're going to see some stuff here, and we're going to think, I can simplify. You can't simplify yet because you have to do keep, change, flip. So I will keep my first fraction and let that be 28 over 5 still. I'm now going to change my sign from division to multiplication, and I will flip my fraction to 4/15. I want to check to see if I can do any simplifying. Unfortunately, I cannot. So I'm going to have to multiply the numerators together and the denominators together. And so 28 times 4, let's see here, that's 2, we'll carry a 3, and that will give us, let's see here, 112. And so we'll have 112 over 7 times, oh sorry, not 7, 15 times 5, so 15 times 5, that gets a 5, carry a 2, 5 plus that 2 is 7, 75. And so when we're dealing with fractions, sometimes we'll get nice clean numbers, like, we'll get 21, or we'll get a nice little fraction like 1/2. Other times though, we're going to get seemingly awkward numbers, 112 over 75. It might not feel like the right answer, but it is the right answer. All right, so now let's talk about adding and subtracting. So this is where we have two options. I'm going to show you both. So the fail-safe, and you'll never go wrong, is if you use improper fractions. And then the other way is where you just deal with the numbers and then the fractions separately. All right, so let me use the same numbers, 5 2/3 plus 3 3/4. So we now should know that this is going to be 5 3/5. Let me clean that up, sorry. All right, 5 3/5. So we should know at this point that it's going to be 28 over 5 plus 15 over 4. We need to get a common denominator, which unfortunately is going to be a rather big number because we have to times everything by 5 and 4. And when we do that, our common denominator will be 20. Now, fortunately, we already did the work. 4 times 28, that is 112. And 15 times 5 is 75 over 20. We now have our common denominator, so we can combine them. And let's see here, so 112 plus 75 is going to be 781. 187 over 20. Again, a bit of an awkward number, but it's the answer. And we will box it and walk away. And the beautiful thing when we're dealing with improper fractions and whatnot is that we can leave things as improper fractions. We don't have to do anything else with it. Now, like I said, there's another option. And this one might be kind of nice because those numbers were a little bit difficult to work with. But what I'm seeing, let me rewrite it, 5 3/5 plus 3 3/4, 3/4, not 4/3, 3/4. I can just add my numbers separately, so I'll do that, and I'll add my fractions separately, and I'll bring it all together. And so I'll get 5 plus 3, which is 8, and then off to the side I'll do 3/5 plus 3/4. Now I'm going to have to get that same common denominator of 20, but it's much, much easier to find that common denominator, or to find the numerators, when there are only 3. So I'll have to times 3 by 4 and by 5. So I'll get 12 plus 15. And as a result, I'm going to get 27 over 20. Now here's the catch. That's greater than 1. So really, this is 1 7/20. I'm now going to take this and I'm going to add it there for my final answer of 8 plus 1, which is 9 7/20. Box it, walk away. Now, same thing's going to happen if we're dealing with subtraction. So last operation, we're almost there. Here, again, you will never go wrong if you use improper fractions. So let's just show you. 5 and, oops, I like to use a different color here. Let's go with that. 5 3/5 minus 3 3/4. Now, fortunately, I've already done all the legwork. I know it's going to boil down to 112 over 20 minus, in this case, now because I'm dealing with a new problem, 75 over 20. So let me write that. 112 over 20 minus 75 over 20. So again, if you need to, you do failsafe and you use improper fractions, you get the common denominator, and now we just do the subtraction. So 112 minus 75, that's 7, that's a 0, 3, so we're now looking at 37 over 20, and we see if we can reduce it. We can't. All right. Again, the main reason why I have this here, though, is I want to show you what that other method looks like, because sometimes it is convenient, it is useful, but there is something you got to watch out for. And this is embedded in this problem here. So we have 5 3/5 minus 3 3/4. And so what we can do is think of this as like 5 minus 3, and then 3/5 minus 3/4. Now here's the problem we have. 3/4 is larger than 3/5. Little awkward. So what we're going to do is we're going to borrow from this 5, and we're going to make it a 4 now, and we're going to take a 3 over 3, or so not a 3 over 3, we're going to take a 5 over 5, and we're going to add it here to make an improper fraction, a smaller improper fraction, and that gives us 8 over 5 minus 3 over 4. Now we can do this subtraction here, and our resulting whole number is going to come from 4 minus 3, which is just 1. We'll need to get a common denominator, so it's still going to be 20, and we'll times this one by 4 over 4, this one by 3 over 3, or sorry, 5 over 5, and so we'll have 32 minus 15 over 20, not 4. And when we do that, we're going to be left with 17 over 20. Finally, we combine these two together, and our final answer is 1 and 17/20, which is the exact same as 37 over 20. So I know that's a lot for you to process. I'm sorry for the length of the video here, but I wanted to go over what you do with mixed numbers. Ultimately, I can't stress it enough, you will never go wrong if you convert everything to an improper fraction. When you're doing adding and subtracting, though, you can work with the number components and the fraction components, but there are a couple of catches. Sometimes you might need to borrow, or when you add the fractions, you'll go over one, you'll need to carry it over. But you can do it. As for the actual the mechanics of performing these operations, it's the same thing. You'll multiply the numerators together and the denominators together for multiplying. You simplify if you can before or early, so that way you deal with smaller numbers. When you divide, you'll still have to do keep, change, flip. And then adding and subtracting, you have to get common denominators. It doesn't matter. So make sure you still have that common denominator. Let me know if you have any questions, and good luck on your homework or practice.